Hi, so today I'm going to show you how to do some integration by substitution questions. This particular video is going to go through some of the easier type questions that you can get. All of these that I'll be going through today are exam style questions. So I'll walk you through my thought process and how I sort of deal with these. Bear in mind that substitution questions can come with varieties of different types. And the methods you'll have to adapt in some situations. So I'm going to go through quite a variety of examples so you can see how they might be slightly different. So yeah, I hope you enjoy the video. Please like and subscribe if any of this helps you, and please share the channel if you find this might help someone. Okay. So let me just start by writing that. I tend to follow a very logical step-by-step process when solving these. So obviously I've wrote the integral. The next thing I'm going to do is write down the substitution they gave us here, which is that u is 2x plus 1. You should notice that that's already dealing with this part here. So there's already something to be substituted for that in terms of u. So that part there is absolutely fine. But you can see that we have this x over here, which we will need to deal with later on. What I tend to do though first of all, is I just start with this substitution expression, and then I just start by differentiating it. Okay? So this is the way I tend to do it. I write du on the left, and then I differentiate 2x plus 1, which gives us 2, and then just write dx on the back. If that confused you, I'm going to show you where that comes from. So the way they usually teach at school is to find du dx. So if I differentiate this expression with respect to x, I get 2 for this. And then if you just times both sides of this by dx, it will lead to the expression that we have here. I just prefer to do it this way because it's easier than to rearrange for dx. Okay? So let me just remove that. Okay. Now if you look, I've already got this part sorted out. I now need to sort out the dx bit, which is at the back. So that's when I take this expression and I will rearrange for dx. Okay, so at the minute dx is times by 2, so let's just divide both sides of that by 2, giving you that dx will be equal to du divided by 2. Okay. So what I'm going to do is just rub this out now. I actually don't need this anymore. In fact, I'd rather have these looking clear. So that would be my substitution for that part. dx will be my substitution for that part, and so I can provide a tick here as well. The last thing I need to worry about is this x over here. In some integration by substitution questions, you won't have to worry about these stray x's that are here, because sometimes they'll be cancelling when you substitute in for dx. But in this particular one, you will find that there is only a 2 here in the denominator. There's not an x in the denominator, so it won't cancel with this part at the front. So in that particular case, what we then need to do is we need to use the expression for u again in order to find a rearrangement for x. So that needs to be rearranged for x. And so what we'll find then is if we take the 1 to the other side, we'll get that 2x is u minus 1, and therefore x will be u minus 1 divided by 2. And you see then I also have a substitution there for x, which can go here. So I have something for everything there. Next thing to do is to just substitute everything in. Okay, so for x, remember we have u minus 1 divided by 2, which I'll put there, so that's x. Then I have the square root of 2x plus 1, remembering that our substitution was u equals 2x plus 1. So if we have a square root over this, this will simply be u to the power of 1/2. And then finally dx we need to sort out. So our substitution for dx was du over 2. Like that. And now it's just a case of simplifying everything. So let's go down a little bit. First thing I can do is I can think about these 2's at the bottom. Now if I times these 2's together, both of them in the denominator, that will give me a 4. So I have u minus 1 over 4 times u to the power of 1/2, and then I have du at the end. I can do a little bit more to this. So whenever you have a fraction within an integral or any constant, you can see I have a divide by 4 here. Effectively it's a 1/4. I can take that out of the integral at the front. So I put the 1/4 there at the front, and everything else will be left inside. So we have u minus 1 and u to the power of 1/2 there. Okay. Then what we can do is multiply out this part here in the integral. So u times u to the power of 1/2. Remember in our power rules here, there's actually a power 1 there. So if we add the powers, since we have the same base, that will give us u to the power of 3/2 for that one. And then just times in this minus 1 by u to the 1/2 gives us minus u to the 1/2 du. And what you should see is that that is exactly what they asked for in the show that. And so here we are done. And usually at the end of a show that question, when you have the thing that's required, we write QED. It's basically Latin to say it has been solved. Okay. All right, let's go to the next question. So here's another one. I'm going to follow the same process again. Each time I'll get a little bit faster so you can just quickly see what's important here in terms of steps. So again, just writing our integral. All right, so let's write down the substitution, which was our first step last time. U equals x squared plus 5. First thing to do is to differentiate u. Okay, so remember we can just write du on the left. Then we differentiate this expression. So the 5 is just going to go to 0, but the x squared will differentiate to 2x. And then don't forget to attach on the end of this dx. Again, if you'd prefer to do it the other way, you're absolutely fine to do that. Instead it would be du dx. Then we differentiate this expression, which gives us 2x. Again, you can then move the dx to the other side, and it gives you what I have here. But the goal here, remember, is to always get rearranged for dx. So rearrange for dx. because remember you have one there. Okay, so if I use what I have here, you have 2x times dx on the right side. If I want dx on its own, I'm just going to divide left and right by 2x. So that gives me dx equals du over 2x. And you can see then I have a substitution for dx. So let's just make a note of what we have sorted out already. Since we've got that u is x squared plus 5 here, then that will sort out this part under the square root. So all of that bit is done. We have a rearrangement here for dx, which can go there, and so we have sorted that part. Now you might be wondering about x. You might be thinking, do we need to rearrange this to get something in terms of x? The answer here would be no, because if you look here, we actually have an x in the denominator of this substitution. So when I put that here for dx, you already have a divide by x to cancel out this x at the front. So you see how this example is slightly different to the last one, in that you don't actually have to find a substitution for x using your u, which is nice. So I don't need anything else. This has actually already been sorted out. So let me now go ahead and do the third step, which is to substitute. So I'm going to write my integral there, so I have a bit more room. So first thing in your integral, as you see, is x. So let me just write that. Okay, brilliant. Next thing, we've got the square root of x squared plus 5. Now if x squared plus 5 is u, then all of this is just going to be u to the power of 1/2. Which you can write there. And then dx, remembering that we have this substitution. So we have du over 2x. Right, so let's have a look at simplifying then. You will notice that the x at the front cancels with this x here at the bottom. So let me just simplify. So that means we only have u to the half left. We have du, and then we have divided by 2. Remember, again, constants like fractions and things like that, numbers within an integral, can just be pulled out of the front. So this divided by 2 is effectively a half within the integral. We can pull that out at the front, leaving us with u to the power of a half du. Now this is just essentially a first year integral now. So we just raise the power by 1 and divide by the new power. The half's going to stay there for now, and I perform the integration on this, giving us u to the 3 over 2 times by 2/3. And don't forget the plus c constant of integration, since it's indefinite. And just finally, doing a bit more simplification, noticing that our 2's here will cancel. And so this will finally lead to 1/3 u to the power of 3/2 plus c. Now again, what people tend to forget to do is to substitute in the u at the end. So, remembering that our u right from the start was x squared plus 5. So, essentially this can be put back in terms of x. X squared plus 5 it was, wasn't it? So, x squared plus 5 to the power of 3/2, and then plus c at the end. This is the final answer for this question. Now, you will lose a mark in the exam if you forget to write the plus c, because remember, for all indefinite integrals, meaning when you have no limits here, you should always have a plus c at the end. Okay? So that is the answer to that one. So in the last two examples, you can see they are slightly different. Let's look at another one. Right, so let's try write that down. we've got x, 3x minus 1 with a square root on top, dx. Let's write the substitution again. So u being 3x minus 1. And let's start by differentiating. I would always advise to differentiate as your first step, because what you might find is when you differentiate this expression, you might figure out that something will cancel out, meaning you don't have to substitute in for everything. Now, you will obviously need some practice to start spotting this, so I'd advise you practice with a lot of these integration by substitution questions to get into a bit of a flow with how it works. So yeah, let's start by differentiating. So we get du equals 3 this time, because remember 3x minus 1 differentiates to 3, and then dx on the end. Don't forget to rearrange then for dx, because remember we need that. So here you're just getting dx being du over 3. So let me just tick that. I have that sorted. Remember u is 3x minus 1, so that's sorted. And then I'm asking myself, if I look over here, do I have an x in the denominator? No, I don't. So that means I need to sort that out as well. So if you need to sort out something here, then you need to go to your u substitution again. So we have u equals 3x minus 1. We need to now rearrange for x, so we have something to put there. Okay, so that would be u plus 1 divided by 3. Okay. And I like to make sure everything is ready. We have something for everything now. It's nice to do this ticking business, because then you can be quite happy you're ready to substitute. So do all of your bits first and then substitute. Don't start substituting one bit at a time. Do it all in one go. It will be better and you'll notice things will cancel. So step 4 will be to substitute. So x is our first thing that we have. So we have our substitution here, which will be u plus 1 over 3. So that's x. Now we have the square root of 3x minus 1. If u is 3x minus 1, this would be u to the power of a half. And dx at the end, remember we have our substitution, which is du divided by 3. There we go. So everything's in terms of u. Now, let's see what we can do to simplify. So we've got u plus 1 multiplied by u to the half here. And then we've got a 3 in the denominator here and a 3 in the denominator here. If you was to multiply these two 3's together, it will give you 9 in the denominator. But I will be pulling that out as 1/9 fraction at the front. So those 3's have gone. Then all I have left is u plus 1 multiplied by u to the half du. Then we're going to multiply out that bracket, which will give us u to the power of 3 over 2 plus u to the power of 1/2 du. Then we can perform the integral. This is actually quite nice now because it's turned into effectively a first year integral. I'm going to leave the 1/9 at the front whilst I integrate, raising the power by 1 and then dividing by the new power. We have u to the power of 5 over 2, and then if I divide by 5 over 2 it will turn into 2/5 at the front. And then let's sort the other one out. So we've got u now with the power of 3 over 2. This time the division will turn into 2/3 at the front of that. And don't forget to add in a plus c. Okay? Then everything just needs to now be times by this 1/9. So this will lead to, let's do 9 times 5 here, 45. So we get 2 over 45, u to the 5 over 2, plus, and then we have, again, 9 times by 3 here, being 27. So we have 2 over 27, u to the power of 3 over 2, plus c. The only thing to remember to do now is to put your u back in. So u is 3x minus 1. So the only thing you need to make sure you do here is to effectively put 3x minus 1 everywhere that you see u. Apologies, this is a little small, but you get the idea. With the plus c on the end. And I'll just put this in a box. So you're aware that this is the final answer. So yeah, effectively you was mostly there. Here you just needed to put u back in at the end, which is what a lot of students forget to do and they lose the mark in exam. So don't forget that. Okay, here's another one. Practice makes perfect. So let's continue. The integration of 4x divided by 4x minus 3 with respect to x. Let's write u, which is 4x minus 3. So let's differentiate both sides of that. Given us du equals 4 dx. Then rearranging for dx, I'm just going to divide both sides by 4. So dx is du over 4. And I have that sorted out. Obviously u is 4x minus 1, so that's also sorted out. But then you've got to think, if I look in there, I don't see any x in the denominator, and so it won't cancel that x there. So in this particular question, it's like the first one we did, where we would need to actually now rearrange this so we can get 4x in terms of u, which is pretty easy since we've got 4x minus 3 here. If we just add 3 to the other side, then that gives us that 4x is equal to u plus 3. And so we also have a substitution for the 4x in terms of u. So we just need to whack these 3 parts in and substitute again. So 4x is going to be u plus 3 at the top. The 4x minus 3 at the bottom is just going to be u. And the dx itself will be du over 4. So first thing I would do is pull out that 1/4 at the front. That's sorted that bit out. Then if you notice, I've got u plus 3 over u. This can be split into 2 fractions. So u divided by u will just give us 1. And then 3 divided by u, I'll just write as 3 divided by u. Don't forget the du is also on the end there. And then this is easy to perform now. Let's keep the 1/4 there for now, like we do. Integrating 1 with respect to u just gives us u. And then 3 over u will go to 3 ln u. Don't forget the plus c on the end. And then just putting the 1/4 through all of that, we have u divided by 4 plus 3/4 ln u plus c. Don't forget u was 4x minus 3, and so we put that back. 4x minus 3 over 4 plus 3/4 ln 4x minus 3 plus c. And that is your final answer. Okay, so here we're getting a bit harder. 6-mark question. Let's see if there's any differences. Integration of x squared over 2x minus 1 with respect to x. This time our substitution u is 2x minus 1. So again, let's differentiate. There we go. And then rearrange for dx. So that's given us a nice substitution for that part. U is 2x minus 1, so we have that bit. Then we look in here. Is the x squared sorted out with this? Absolutely not. So that means we're going to need something else to get x squared in terms of u, which is where we use this. Okay. So if u is 2x minus 1, that means that 2x is u plus 1. And then x within itself, dividing both sides by 2, would be u plus 1 over 2. And then I need x squared, remember. So let's square both sides. X squared, and then let's square what we have here, remembering it's a fraction. So u plus 1 squared, and then squaring the 2 as well gives us 4. So here's our substitution for x squared. And that means we've got that sorted. So substitute now. X squared, substitution is down here. So I'm going to write u plus 1 all squared over 4. And then if you notice at the bottom, we also have 2x minus 1, which, don't forget, is our u. So I can just write a u there next to it. If you don't like that, you could split these up and just have that as 1 over u next to it, but I don't see the point. I think it's easier just to have a u there. Okay. Next thing is to sort out the dx. So we have the substitution there for dx, which is du over 2. Right. And let's simplify. So again, we've got 2 at the bottom, we've got 4 also at the bottom. 4 times 2 gives us 8, so I'm going to drag out 1/8. I would do that first because it makes it look a bit simpler. Next we have u plus 1 squared at the top still. The 4 and the 2 have now gone. There is a u at the bottom still, and a du at the end. Next thing I would do is expand the u plus 1 squared. Sometimes I prefer to just remind myself it is like this. Expand that out, giving you u squared plus 2u plus 1. Okay. So effectively this is 1/8 integral. We have u squared plus 2u plus 1 all over u, and then du at the end. Just concentrating on this part here, what you should see is that we have a u squared divided by u, we have a 2u divided by u, and a 1 divided by u. Just give myself some more room. Okay, So this is going to go to 1/8 u squared divided by u will just be u itself. 2u divided by u will just be a 2. And then 1 divided by u is just 1 over u. Don't forget, I should still, apologies about that, I should have wrote my integral symbol and then du at the end. Then we can perform the integral itself. We have 1/8 still. Now integrating u with respect to u gives us u squared divided by 2. Integrating just the 2, the constant, gives us 2u, and then 1 over u going to ln u. Don't forget your plus c on the end again, since there's no limits on that, remember, so it's indefinite. And the last thing is to remember u is 2x minus 1. Please don't lose that mark at the end for forgetting to substitute it back in. So what was it? 2x minus 1. There we go. If you wanted to, you could multiply this 1/8 through. I might just do that just so it's complete. So we've got 2 divided by 8. Let's go to a quarter. And then 1/8 times ln, giving us 1/8 ln 2x minus 1 plus c. I'm pretty sure they'll be happy with the one above, but just in case, that is the fully simplified answer. Okay? So I'll try this one. I'll see if there's anything different. Oh, there is, of course. What do we have here? Limits. So I've not actually shown you one that has limits yet. This is the first one that has limits. So this will be bringing in something else to think about as well. So test yourself on this. So we have 1 and 0, x, 3x plus 1 under the root with respect to x. Substitution in this case is 3x plus 1. This will go to du equals 3 dx. And remember, to get dx, we'll divide by 3. So that's got me that sorted. I've got my 3x plus 1 sorted there. And then looking in here, again, there's no x there. So I need to sort that out as well, which comes from here. Rearranging that for x gives us, so 3x will be u minus 1, so that means that x would be 1/3 u minus 1. So I need that, and I need that. Those are the 3 things I need. Brilliant. Now, there's one other thing to consider now we have limits. So these limits, the 1 and the 0, are what we call x limits. Well, we don't need x limits, we need u limits. So I'm going to sort that bit out now. I'll write this over here. So I will just do this limit section, makes it your life quite easy. So if we just write the x limits, we have x equals 1 and x equals 0. Now all you need to do is use your substitution for u. So u would be times an x by 3 and adding 1. So if I do 3 times 1, that's 3, add 1 is 4. So u here is 4. And here 3 times by 0 is nothing, add 1 gives us 1. So these are the new limits we need to use if we are doing it in terms of u. Please don't forget that if you have limits, because you will lose a mark. And remember, the limits also need to be subbed into it, so you'll end up with a wrong answer if you don't change the limits. So effectively there's 4 things to worry about here. There's the u, the dx, the x, and the limits. Noticing the marks are going up now. Okay, so we're now substituting into this. So first thing, let's change the limits, which are now 4 and 1. X, remember, we have this, so we're going to write 1/3 u to the minus 1 in place of x. 3x plus 1 is u, but with a square root on top, that will be u to the half. And dx, remember here, is du over 3. So 4 things to worry about. Let's put those back on. Now we have, notice we have the 3rd here and the 3. So 3 times 3 is 9. I'm going to pull it out as being 1/9 at the front, leaving us with u minus 1 times by u to the half du, and this can be multiplied out. Which will give us u to the 3/2, take away u to the half du. I'm going to leave the 1/9 there for now, whilst I perform the integration. So the first year integration again, raise the power by 1, divide by the new power. That will be u to the 5/2 with a 2/5 in front of it. Remember, it will always be the reciprocal of whatever power you have here if you divide them by that. Just the easier way to remember it. That'll be u to the 3/2. Reciprocating 3/2 is 2/3, so that'll be at the front. Plus c. Oh, sorry, no plus c. We have limits. Apologies. Done so many without limits, I forgot. So there you go, just like I just said, it's so easy to forget and lose a mark. Don't forget. Now, 4 and 1, that's all we need. I know most of you use a calculator at this point, but it's good to show you working out, which I will do. So it's 2/5. Essentially, we're putting in. So we'll start with a 4 then. So yeah, of course, this would then all just go in the calculator.